So let's look at this next example. 10 students are competing in the Smart Smil talent show. In how many different ways can all the contestants place? First place, second, and so on. And that is assuming that there are no ties, no two students in the same placement. Just like we did in the first part of this tutorial, for first place we have 10 different possibilities, since it's 10 students. Now if one is in first place, then we still have 9 possibilities for second place. Then we have 8 possibilities for third place, 7 for fourth, and so on and so forth. But you already realized what this is going to be. This is going to be 10 factorial. And that would be 3,628,800. But in how many different ways can we arrange it if we only care about 3 of the students making first, second, and third place? If we only want to know who the first 3 place students are, we have 10 possibilities for the first one. And once that's taken, we have 9 possibilities for the second, and then 8 possibilities for the third. And we don't care about anybody else. Then we would be able to calculate it this way. And there's also a formula that we can use. It's permutations of N objects if we take only R of those N at any given time. And the formula for this is down here. And it's n factorial divided by n minus r factorial. In our example up here, that would be 10 factorial divided by 10 minus 3 factorial. And how does this formula relate to the way easier way here to the left, 10 times 9 times 8? Well, 10 factorial is 10 times 9 times 8, and I can't keep going, but I'm just going to say now times 7 factorial, because that includes all the numbers from 7 down to 1. And that gets divided by 10 minus 3. Well, 10 minus 3 is 7, and for the factorial of that. So we have 7 factorial also in the denominator, and these two cancel each other out. So we end up with the same 3 numbers multiplied here as we started off in the beginning. And there's also a special notation for this. The way it's written is 10 permutation 3, just as it is down here in our formula. And on the calculator, there's also a way to calculate this. But I'm sure that for this one, you've already done it in your heads, and you have figured out that the answer to that is 720. But the calculator will come in handy for sure in our next example. You're making a list of possible hikes on the Appalachian Trail for fall break. You have 10 available hikes, but only want to go on 6 of them. How many different potential itineraries can you make? Itineraries, so how many different schedules can you make of going on 6 of those 10 hikes? Well, we have 10 possibilities, and we want how many permutation of 6 elements out of those 10? 10 permutation 6. And now we're going to use our calculator, and we find this in the same place where we found our factorial. Math, go over to probability, and n permutation r is option 2. So we have our notation here, and all we need to do is fill in our numbers. 10 permutation 6, and that gives us an incredible 151,200 different possibilities of going on 6 out of those 10 available hikes. But what if the order of the different hikes that we want to go on doesn't matter to us? Or if the order in which we arrange certain objects, like the letters A, B, C, D, E, F, if we didn't care, and it could as well be B, C, D, E, F, A, if those were the same to us, then we no longer talk about permutation, Then we have what is called a combination. A combination is when we arrange the different objects, but we don't care about the order. We just care about which ones of these objects are we taking. For combinations, we also have a formula here. So in our example of our hikes, how many different trips can we take if we don't care about the order in which we're taking those trips? This we would do in a similar way to our permutation. We can write 10 combination 6 this time, and we're also going to use the calculator to figure that one out. And the combination is in the same place again. So math over to probability. Combination is number 3. 10 combination 6 would be 210. And did you see the huge difference it makes if we don't care about the order of the objects that we are arranging? Before we had 151,200, and now we just have a mere 210 different possibilities. Playing cards are a perfect example for this. Here in our next example, we have a deck of playing cards that has 52 cards. How many ways are there to deal a 5-card hand? It doesn't matter to us in which order we're being dealt those cards, right? And it doesn't matter whether we put the deck on the left in our hand or on the right. The order doesn't matter, and therefore we do not have a permutation, we have a combination. So if we have 52 cards that we're being dealt from, and 5 are going to be in our hand, we're going to write this as a 52 combination 5, and let's see what our calculator spits out. Math prob 3, 52 combination 5, and the answer is 2,598,960 different possibilities of having a hand dealt that way. Wow. But how many 5-card hands could we have that have all 5 cards the same color? How many different colors can the cards in a deck of cards have? They can be either red or black, so we have 2 different colors. But once we have one color, there's only half of the cards, so only 26 cards left that actually work. So we have to take these 2 things and put them separately in our formula. So first we have the combination of colors, 2 possible colors, but we only want 1. And then we have the combination of 26 possible cards, but we only get 5. And these 2 different things have to be multiplied by each other. How many choices do we have to pick a color out of 2? That is 2 choices. And then we have 65,780 possibilities to get a hand of 5 cards dealt. That means in total 131,560 different hands that are all the same color. Alright, you guys, that's it for today, and I will see you in class.